My name is Wim Slachter at ANSYS. I will be the host and moderator of today's webinar entitled JSP Running ANSYS LS-DYNA with HPC to Boost Productivity. We are joined today by Nurul Huda at JSP and Rod Mack at TotalCAE. And it's being in conjunction made with Adnan Khalil at Dell Technologies, who is unfortunately not able to make today's webinar. But thanks for Adnan's contribution. Before further introducing today's speakers to you, let me mention that this webinar is actually part of the IT Solution webcast series at ANSYS. And for those who are not fully aware of this series, I'd like to say a few words about this initiative at ANSYS and also our goals in actually promoting it to you. Basically, this webcast series is the place where ANSYS and our HPC and cloud partners are pulling together recommendations and information that we hope can help guide your IT decision making, whether that is on specifying the best systems you can run ANSYS on, or maybe developing ideas for running ANSYS even in the cloud. And on this slide, you can see some of the topics we have already been addressing. For example, improving engineering simulation productivity with HPC, understanding how HPC can accelerate simulation throughput, and more. And the full list of webinars held so far can be found through the link that I'm showing here on the slide or in our resource library on ANSYS.com. So please consider this really as an invitation to regularly visit our IT and Cloud Webcast Series page on ANSYS.com and make sure that also your colleagues, your engineers are aware of it too. So let me move on. So this slide is really meant to show you that our IT webcast series is part of a larger focus at ANSYS on IT solutions. We believe really to be able to predictively deploy simulation that you need a right infrastructure. And that we need to engage with you on best practices and how our software fits into your IT environment, so to say, in the best way. So, and because IT is really the enabler for more effective use of simulation, you can say that IT matters are clearly driving also our product strategy and our engagement with IT industry partners, including Dell Technologies, including system integrators like TotalCAE, who are part of this webinar. And as you can notice on this slide, we clearly observe three major simulation trends impacting IT, so to say. The first one is the trend, and that's actually related to this webinar. It's the ability to do bigger, more challenging simulations, more challenging LS-DYNA simulations, and to get even higher fidelity insight into how your product or process design is going to work in the real world. And the second major trend is the ability to do more simulations in less time. And you will hear our guest speaker, Nurul Huda, about it as well. And the third one is really to provide simulation tools to more practitioners and more engineers who are working in distributed teams, geographically distributed teams who need to collaborate on common simulation projects. And all of these trends put high demands on IT and to support engineering at a new level. And here I'm a bit provocative by this statement, and engineers are wasting time. And I can make that statement because in a very recent large survey among our customers, about a quarter of the respondents said that they limit the size or amount of detail for nearly every model they run due to turnaround time limitations. And almost half of the respondents said that they impose these limits on at least half of the time. And the chart on the right refers to the same survey, actually, in which the respondents stated that how often, actually, they are limiting the size and amount of simulation detail would then lead to low fidelity results. And as you can notice, for more than half of the respondents stated that this would be the case in more than half of the time. So it is very obvious that many engineers are constrained to compute capacity. Many of them spend quite a lot of time and effort in adjusting the model size and complexity. And for that matter, we are having this particular webinar. That brings me really to today's agenda and speakers. First of all, it's a great pleasure to introduce our guest speaker, Nurul Huda. Nurul is Senior CAE Product Developer Engineer for JSP, and JSP is the leader in engineered foam products. Nurul manages JSP global FEA applications and coordinates CAE application of GSP R&D for material and product testing and validation. Nurul has a master's in mechanical engineering from the Wichita State University and an MBA from Wayne State University. I'm also pleased to have Rod Mack from TotalCAE in this webinar. Rod is president of TotalCAE, a managed HPC service provider for engineers and also an AWS partner. Rod is a 25-year veteran in utilizing high-performance compute and IT technology to advanced engineering, simulation, design, and manufacturing. Rod has a bachelor in electrical engineering from the University of Michigan. And because Adnan is not able to make it, I still want to introduce him. Adnan, and by looking at his bio, Adnan is a seasoned business development professional with over 20 years of experience in high-performance computing and machine learning. Currently, Adnan is leading global HPC sales strategy at Dell EMC, and with his strong technical background, Adnan works very closely with customers in helping them to choose the optimal HPC solution. So, and last but not least, we will have a Q&A, a questions and answers session at the end of this webinar. And let me now hand it over to our guest speaker, Nurul. So please, I will give you the control to advance the slides. Please go ahead, Nurul.
Thank you, Wim. Thank you for the introduction. Hello, everybody. It's an honor. Thank you, ANSYS, for giving me the opportunity for this presentation. And I'm actually glad that to be a part of the ANSYS family again. 20 years ago, with my experience with almost 20 years in LS-DYNA application software use, I actually started my work with ANSYS in my academic years at Wichita State University. So it's nice to actually be a part of ANSYS team again when they acquired LS-DYNA. So without further ado, I'll start the presentation. Today's presentation, I'll be mostly focusing on how in JSP we boost our CAE capability and productivity from the help of TotalCAE to install and help us with high performance computing system. At the beginning, let me introduce my company. So you can see JSP is a global company. We have manufacturing offices in Europe, Asia, North America, and Latin America. I work my office, I work from in Madison Heights in the United States, about an hour away from TotalCAE's office. We're not too far away from TotalCAE. Little bit of introduction of what we actually do. JSP is actually lead manufacturer of EPP, which is expanded polypropylene. Our brand name is actually RPro. You can see on the bottom different product lines that we have. The material is basically raw material. We are a raw material manufacturer of EPP. This is basically polypropylene-based material. So on the top left corner, you can see the polypropylene is basically extruded in strand format. And then in the next stage, it's been chopped into smaller pieces. We call it mini pellet. And then that is been, with a special process, we basically expand those pellets into EPP small beads. This is the raw material. Depending on the expansion of the beads, we can achieve different densities of APP. After this raw material, we not only actually make this material, we also produce parts with this material, and also we support our customers to make these parts with APP. On the bottom, you can see quite a few examples. We cover a lot of different areas in day-to-day work. The RPro is actually 100% reusable and recyclable. We actually have a facility in Detroit, Michigan, where we actually recycle our product 100%. It's a 100% green product. As you can see, our application is in automotive and non-automotive in wide range. We have automotive seats. Then we have safety items like child car seats, helmet, storage box for food or damage system. We also have HVAC application. We also have a large variety of applications on furniture, underlayment, and these days a lot of toys, like the one you can see here. The main purpose is the product that we have. It's the strength to weight ratio is so excellent. So it's lightweight. It can be applied where you have to actually manage the energy, and it's also lightweight. So that's why the application of our product is that much wide range. With the next slide. Okay. So as a raw material manufacturer, we test our material. We validate our material, and as a customer service, my department, the CAE department, we actually validate the material and model that in the virtual application to apply in the CAE. Looking at the history, as you can see in time spectrum, but when we started at the beginning 1998, it was mostly application of the automotive bumpers, front and rear bumpers. But currently, the product has a wide range of applications. Just in automotive, about over 15 to 20 items in automotive itself. Not to mention, we also have a lot of non-automotive. The one I showed you in the previous picture, and the graph that what I'm trying to show is as we service the CAE service to our customers, when we started at the beginning, our model was small because our application was limited. We had like the small components of CAE components, just the bumper, EA, that was our application. In time, as we start, going to different products, the product spectrum was getting bigger. Our application of CAE to our customer, to our commitment to the customer, also got into different levels. Just not only automotive, now it's in non-automotive. So there is a big spectrum of CAE service that we actually do for the customers, automotive and non-automotive, and the volume also from very small component to very large automotive or both to that nature. I'll show you a few of this example later on. So in order, just a quick history of our CAE, we have a very small team of people in a large corporation. Me, myself, and Paul Chamberlain, he's my colleague. We both are actually two engineers working for JSP and supporting our global need internally for JSP and also for our customers. So you can imagine for a small company like this with vast application, we cannot just, we need a bigger help from somewhere. When we started, we had a very small core CPU Windows-based server, and our IT only services Windows-based. So as the product and the applications start growing, we're getting more and more challenge of getting bigger models, more complicated models, and more diverse applications. So we were getting into the need of expanding. So we're thinking what to do next, how to actually tackle all these requirements, all these needs. So we start looking internally to see how we can improve. So we went from 4 CPU to 8 CPU, and then it was kind of roadblock there. So we can only do as much. Because all the installation of the software, of all the software that we're using, was done by us, not the IT. IT was supporting us hardware, but all this installation, license, everything, we engineers were actually taking care of it. So you can imagine as the workload of CA is already a big thing, and in order on top of it to maintain and manage all this license once it expires from the installs, it's another hassle. And then when it comes to bigger jobs, we couldn't keep up with our work to the technology. So we're fortunate. Our management, they are always want to use state-of-the-art technology that's available there. So from that perspective, I've been tasked to see what would be the next step. How can actually we can achieve, we can support all our needs within our limitations that we have. So that's where TotalCAE came in. They actually helped us to install and a high-performance computer. From my academic background, I worked with a Linux-based system in the past, and my colleague, we are able to run with commands, we can install softwares and those kind of things, but in order to actually manage the whole full cluster, or not even HPC, but just regular multi-CPU machine, it was a lot of work for us, and our IT only supported Windows-based. So when in order to get to the next level, we had to actually go out of the Windows-based and get into Linux or Windows environment. And of course, our IT could not support, so that was a big hurdle for us. But when we discussed with TotalCAE, they actually not only what they provided is the whole package basically. So it was nightmare for me to actually, I went to Dell, I went with HP and talking to these reps to see, what are the solutions out there, what we can do. I mean, I'm talking about like 10, 12 years ago when there's not too many companies out there that they can help you out with, with this kind of support. With a big company and with with a smaller group of CAE people, it's the budget is another issue. So I mean, if you choose to go one direction, and if it's not correct, that can be devastating. I mean, so risk is another issue as well. So we were lucky to actually, because in one of those LS-DYNA's global conference where I had a chance to meet the TotalCAE, they basically take over our cluster, our whole CAE hardware. So not only they manage our hardware, they install the software, they manage everything. So basically taking almost 50% burden that we actually were dealing with prior, and we can now focus on our actual work and analysis. Not only that, as it is a Linux-based, we're not getting support from our internal IT. The TotalCAE has a web-based portal, which was very easy because before that it was like for us between us engineers, we have to manage and communicate ourselves who needs to put the job first and whose job is working and whatnot. It was very difficult for us to actually manage those work. But TotalCAE's web-based portal that it's very easy to use. Just log in from the web and then you can see who's running the what job, what percentage, and those kind of things. Those helped us tremendously. And that way we know how long the job is going to take, how the CPU is being utilized, not even knowing how the hardware part is going, which is basically all we needed, because then we can mostly focus on our analysis work. So I'm just going to show you in the next few slides. I try to put those different level of complexity in work that we do. That it's kind of a nightmare when you do this kind of analysis, and also at the same time, if you have to manage hardware and the software for this. So let me show you a few of the simulations that we do. On the top left corner, you can see the furniture. These are static analysis. We do implicit, explicit analysis, static, dynamic. We do Lagrangian analysis, and nowadays we're doing quite a few ALE, SPH, DEM, and some CFD. And all these are different kind of field of expertise, and merely just to be keeping up with different kind of analysis, if there's another burden of maintaining and managing cluster, that's a total nightmare. So as you can see, once this the extra burden for this hardware been lifted, we are more focused on our day-to-day application and service our customers way better than we could do in the past. So as you can see on the bottom left corner, it's a kind of a static loading condition, but if customer wants us sometimes to do a stack-up analysis, it can end up in the model that you see here. It's about 500,000 elements, but it can go up to 2 billion elements easily if you just stack it up and do the whole analysis. There's a drop test, which is simpler ones. Then we do a lot of stack-up tests for the damage application on the bottom right corner. Then in the next slide, there's some application of RPro in child car seat. So due to the regulation, different kind of analysis based on the regulation we need to run. And this model that you can see, it's about 1.5 million elements. So in order to run this, you need to actually have to run this efficiently and within time, because TotalCAE people know the nightmare of, like, every time the customer comes in, the due date was yesterday. So your timing is of essence. So in order for you to run these detailed models, bigger models, a high performance computer is necessary. And let's move on to some other examples. Then we do some automotive application, frontal impact. We have the RPro is applied in the rear seat. We kind of take away the traditional one. There was a lot of wires in the rear seat, and those are mostly for the structures. So our structural EPP foam that we use, that reduces the weight and the wires about like 35%. We have a lot of application of rear seat in automotive, and they, depending on what kind of dummies you use, 1, 2, 3, what percentage and what details, they can run up till 2, 3 million elements easy. And in order to handle those, you need high performance computers. Next application, this is analysis of tsunami boat, and we have used about 25 dummies in this analysis. The boat is about 28 feet long. There's about 4 million elements in modeling this. There's the model was done with adhesives, and there's a lot of fasteners throughout the boat. So the whole detailed model to run this kind of analysis in high performance computer was a really, really big boost for us. We were able to run tremendous amount of runs for the customers and achieve the target there that they were trying to achieve within the time frame. And another example, as I mentioned, this is the typical tool. On the left-hand side, you can see on the top, there's the part of the tool. At the bottom, there's a thermal image of the tool. So we do thermal analysis of the tool. As you can see in the middle, that's the whole tool. It's about 3.5 billion elements for this one. So we can actually run analysis on the tool to predict if there's any issues with the tool, the stress, thermal analysis, and those sort of things. You can imagine it's about, the window is about 8 feet by 4.5 feet. So the gigantic model, and to run different kind of analysis. I mean, it's impossible, almost impossible to run in regular machines. So high performance computers must for this kind of analysis to get reasonable result with reasonable time. And also we do some CFD analysis, as I was mentioning. JSP wants to be always ahead of the curve. We try to investigate our R&D, our material application. We try to understand how our material works. So there are some simulations that we're actually working on. This should be a video. For some reason, I don't know, the video is not working. But basically, we're working on the filling simulation of our product. So we are using, we have used SPH, the DEM. Right now we are using DEM to CFD coupling. And even with the cluster that we have, we are still not to that point, but we're working forward to achieve those in the near future. And as I said, in order to accomplish all this kind of variety of work, not only you need the capability of the analysis, but you also need the hardware where you can do one the analysis in time and get the results on time. And as I was saying, from TotalCAE, I work closely with Rod. He's the CEO of the company, but I had issues like in the middle of the night. I mean, you guys know when you run the analysis, all of a sudden, your run is failed. So sometimes in the middle of vacation, you're checking in holiday, you're checking you need some IT support. I sent an email and I have actually got feedback from Rod in the middle of the night saying, and he fixed it the day after. So so far, the support that we have got from Rod's team, it's tremendous, excellent support. And with their support, and as I said, they're taking care of all the IT support on the high performance clusters, we've been able to focus more on the analysis side. So thanks to the Rod and his team. With this, I would like to conclude my presentation, and I would like to hand over the presentation to Rod. Thank you.
Thank you, Noel. Thank you for your very, very interesting talk. I will give a Rod control for sliding through and advance your slides. Go ahead, Rod.
All right. Thanks, Wim. Thanks, Neuro, for the good words. So yeah, I just wanted to say thanks to TotalCAE exists because of customers like Neuro. We are here basically to help customers take simulation runtimes from weeks and days down to hours. So a lot of customers are in that boat. They're on a workstation or they're having a system they're having to maintain, and they really want to get out of that and go to the next level. So we sell turnkey managed HPC clusters and cloud. We then manage that for you, including all the applications, all of the ANSYS suite, whether you're running DYNA, CFX, HFSS, the whole ANSYS suite. We will then install, manage, update, and upkeep. And then we give you a simple-to-use interface like the portal for DYNA. We also, if you want to submit from Workbench, we support RSM. And all of that is combined and managed by us, in your data center, so you can focus on engineering and not IT, like Neuro had mentioned before. So let me see if I can get the slide here. So with our model, there's just one number to call. You call or send an email. We have 1 hour response to all inbound inquiries or 3 rings. A human here and will pick up the phone. We have support staff throughout the United States, and whatever the issue is, we're going to help figure out what it is. So we work closely with ANSYS support. So if there is some kind of issue, we will have diagnosed it all the way up to the model. Now we can't fix the model itself, but we can at least identify, hey, there's something weird happening with this model, and help get it resolved. So you just have one number to call for whatever your issue is, and our team is going to help figure out what's going wrong to make sure you can keep your deadlines. So we are laser focused on helping engineers, like Neuro had mentioned. That is why we exist. And so every single email that comes into the company has a little 3-box check mark. And if you do not rate our team 100%, then I personally will call and find out, what can happen. That has in 2020 we've had a 100% positive rating. So I appreciate our team, working, diligently to keep engineers productive. And, a lot of our responses that we get from our surveys are all about, being able to have good response times, helping people get their jobs done. That's really why we're here. And I just, Neuro had mentioned, there's a quote from Neuro, that, a lot of times engineers do get stuck having to do all the IT in addition to their day job. And so, we're here to help to alleviate that problem, so you don't have to, you can focus on your simulation and not worry about IT, or if you have an issue, you can help, have more peace of mind that it's not the system, it's not the software, you can help laser focus your efforts onto, getting your problem resolved. And so we definitely have a mission of keeping engineers productive and using HPC. So even with the same hardware, software, and people, you're able to get a higher level return. And so with that, Wim, would you like me to handle this? I'm not sure if not.
Yeah.
Okay.
Yeah.
So. Yeah, we definitely work closely with Adnan's team at Dell to do the managed clusters. So we have a turnkey HPC system based on Dell technologies that we then pre-install and deliver it to completely working at your facility. Then we just show up to basically plug it in, and then you're running jobs through that TotalCAE web portal that Nurul had mentioned before. And some benefits is that, we do benchmarking. So if you need to see or prove that you'll get benefit from HPC, if you're not sure, we work with the Dell benchmarking team, and we will, return a result so that you could say, yes, I would benefit from that. And you can see what it would cost to adopt a high performance compute cluster. And our solutions are built on next generation Intel scalable processors. Depending on, so we help you basically curate what is the best choice for you based on your model. So if you're running DYNA, that might be a different type of processor, memory, disk than maybe if you're running HFSS or, ANSYS mechanical. And so we will help, choose which processors and types of hardware technology are best suited for the application mix you have, and then our scheduler will route the types of jobs that you submit to the shared system to the appropriate technology so that you can get the best bang for your buck. And then we will also be able to help you benchmark these various Intel technologies to see which processor would be best for you. Currently, we're on each generation that comes out, from Intel. TotalCAE benchmarks across all of the different applications so that we can make a good advisement to our clients. And so if you're interested and you're not sure if high-performance computing would benefit you, and you're waiting, days and days for answers, then we do have a benchmark program in conjunction with our partners Dell, Intel, ANSYS. We could run that job. We'll give you what the runtime was, and then that will help you justify, like, hey, if I were able to get my results back 10 times faster, could I, what could happen? Could I get lower warranty? Lighter designs, like Wim alluded to, not having to, dumb down the design to get it back in the turnaround you need. You'll be able to quantify the actual benefit and then the dollar amount to get that benefit. And we found this very valuable for customers that are having to speak to management, that they can get quantifiable, provable results on their actual models without having to worry about the risk that Nurul alluded to, that what if it doesn't help me? So this is a valuable program, and, please reach out if you're interested. You can contact us at totalcae.com/DellEMC or at info@totalcae.com, and we will help, tailor a solution for you and your company and the needs that you might have. And I just wanted to say thanks again to Nurul for volunteering today, and for Wim for sponsoring this, Adnan for the partnership. And I'll pass that back to Wim.
Thank you. Thank you, Nurul, and also Rod, for your interesting, informative talk. In particular, I really enjoyed also actually all the applications Nurul was showing. Obviously, it comes along with a lot of engineering challenges, but indeed the point he made about focusing on engineering rather than IT. That's obviously very key, and that makes the solution provided, the appliance that's provided by TotalCAE, which is based on Intel-based Dell technologies, obviously very instrumental. So yeah, I think that that was really interesting. And let me move on to a few wrap-up slides, basically pointing you to check out the partner pages, so to say, on ansys.com. Particularly, there are some very interesting additional resources available on the TotalCAE partner page. So check it out. Go to ansys.com/HPC-partners and find TotalCAE, as well as also Dell. The partner page of Dell. There's a lot of white papers, recorded webcasts, and also assets like what you see here on in the right top corner is actually a very brand new case study with JSP, and based on the work Nurul shared already with you, and you can read further details about their workloads, about why they have actually chosen TotalCAE and Dell technologies to meet their requirements and increase their productivity, so to say.